Hey, what's up, guys? Okay, so in this video that I want to talk about the Legendre symbol, which is another interesting thing in the interesting subject in number theory, and which can go very deep. So I will make a series of video that put this into my analytic number theory lecture. I hope you guys subscribe to my channel. Okay, so that's so this video should be very simple. Just introduce a notation and prove a very simple theorem called Euler Criterion. Okay, so let's start. Okay, so the definition of this Legendre symbol will be just this. So when we define the Legendre symbol, that's so usually it's just defined to be the quadratic residue. Okay, so very simple. A P Legendre symbol is 1 if A is quadratic residue mod P, and A is non-zero. -1 if not, 0 if P divides A. Okay, so quadratic residue means that there is this x such that x squared is 8 mod P. Basically, simply speaking, is that you can take the square roots. You can take square roots in mod P. Okay, so this is the definition. So maybe it's hard to understand. Let's do some exercise. So for example, let's say take P to 5, and I have A equals to like 0, 1, 2, 3, 4. So I can write down a symbol. So 0, 5, which is 0 because 0 divided by 5, and I 1 divided by 5 is 1. The reason is that 1 squared is 1 mod 5, and we have 2, 5, and I don't know whether it's 1 or not, right? But the answer is -1. Okay, and the reason is that you can try to solve x squared equals to 2 mod 5. And you can see that if x is 0, then square is 0. If x is 1, square is 1. If x2, square is 4. And x3, the square is 9, but it's still 4. And the 4 is 1. So 2 has no solution. So it's -1. And the 3, 5 is also -1. And the 4, 5 is 1. Because there is a 4. Okay, so it's interesting to ask whether it has a solution or not. And hopefully you can get this very quick. Okay. So the natural question is that, okay, so there are some natural questions, right? The first natural question is that how to compute AP efficient. And this is weird, I mean, because you hope you can write the right program, right? Easy compute, not just like if P is very large, then you need to do something do other things, right? Or is there any relation between let's say AP or maybe BQ? Okay. Okay, or a simple formula. For example, if I want to ask -1p, I want to ask what is the case that I can take the square roots. I can take the -1. I can square root to the -1 in the mod P field. Okay, so now let me just talk about a simple property. Okay, so these are symbols, very, very simple property. That so simple that I think everyone knows it. So I will not give the proof, but it's very simple. And next, I will give the proof about the Euler criterion. Okay, so let's talk about property. Because all these are very exercise. Okay. So the first one is that if A and B are mod B, then AP is the same as BP. Okay. How do we prove? How do we prove? Let's see. So by definition, right? This is just by definition. Right? Because you can x squared equals to A, mod P is the same as x squared equals B. Okay. And the second one is this. Okay, so this is means that A divided by P is complete multiplicative. If you know like some numbers theory, you will notice what is complete multiplicative mean. Okay. Okay, these are also by definition. Okay, because if two of them have solution, for example, if x squared equals to AP and then y squared equals to BP, then you can get x squared, y squared equals to ABP. Okay, and notice that our FP is a field. So you can check that if you have solution here and you don't have solution here, then there will be no solution here. Okay. Well, these are two simple ones. Okay, so now we are going to talk about some the first non-trivial fact, even the Euler Criterion. Okay, so the fact is the following. So actually A divided by P is just AP minus 1 divided by 2 mod P. Okay, so this is a simple calculation that you can make to prove to just directly compute the Legendre symbol A over P. Okay, so what this means is that simply speaking is the following: AP minus 1 divided by 2 mod P is 1 if and only if x squared equals to A mod P has a solution. Okay. So the proof of this fact is a little bit non-trivial. If you think a little bit, then you will find that one direction is trivial, another direction is hard. Okay, so the proof. So let's prove a simple direction. Simple direction is that assuming we have a solution. Okay, so let's see these directions. So let's say we have x squared equals to A mod P. So x squared equals to NP divided by 2, and AP minus 1 divided by 2. And mod P will be what? Will be AP minus 1 divided by 2. P will equals to this. So this is xp minus 1 mod P. Okay, so due to Fermat little theorem, A to the P minus 1 is 1 mod P for every A. So this is just 1. Right, so if you have any solution that you prove that AP minus 1 divided by 2 mod P is 1, so basically by definition there is a solution. Okay, so now the second directions. Okay, so second direction is tricky, and so we want to show that basically we want to show the following. We want to show that if AP minus 1 divided by 2 is minus 1 mod P, so it's 1 mod P, then x squared equals to A mod P has solution. This is equivalent to saying that if x squared equals to A mod P has no solution, then we must have AP minus 1 divided by 2 equals to minus 1 mod P. Okay. So notice that due to the Fermat theorem, we have AP minus 1 equals to 1 mod P. Since P is considered P is odd, right? So you can always have the following factorization. P is 0. Okay. So which means that AP minus 1 divided by 2 either plus or minus 1 mod P. Okay. So yeah. So we are going to show this. We are going to show if there is no solution, then AP minus 1 divided by 2 must be minus 1 mod P. Okay. So lemma. So first lemma is the Wilson theorem. If you don't know how to prove it, that maybe you check my other videos. Okay, so the Wilson theorem tell you that p minus 1 factorial is minus 1 mod p. Okay. Now the second result that I like to use is the following. So if x squared equals to a mod p has no solution, then what? Okay. Then for each this h belongs to 1 to 2 to p minus 1, there exists a k which is different from h, such that kh is a mod p. Okay, the proof is very simple, right? You can see that because fp is a field, right? So I can choose. I can choose k to be just ah inverse, right? But notice that k cannot be the same as h, right? So the reason is that if k the same as h, means that h is a h inverse. This will imply that h squared equals to a mod p. But this contradicts that I assume there is a no solution. Okay, so that means that for each a, that you can find a pair such that their times will become a. Okay, so that means that that means what? That means that if you go to 1 to 3 up to p minus 1, there will be p minus 1 divided by 2 pair. Their product is a. Okay, so you can product of them. So you get 1 to 3 up to p minus 1 will be a p minus 1 divided by 2, right? Because 2 of them become a. So a p minus 1 divided by 2. And if you mod p, then will be minus 1 mod p by Wilson's theorem. Okay, so that means it's minus 1 mod p. So prove the results. Okay, so yeah. Okay, so it's equivalent to prove that if AP minus 1 divided by 2 is plus 1, right? Because this fact tell you that if it's not minus 1, it must be plus 1. Okay, so x squared equals to a mod p has a solution. Okay, so this is my very simple video, and next time we will talk about the reciprocal that there's a reciprocal formula for Legendre symbol. Hope you guys to see you guys next videos.